Welcome back to CSC 143, Introduction to Data Structures. This is Mighty CS Man, and we are in week 2, going over Chapter 9, Inheritance and Interfaces. Just a quick review. Last week we covered Chapter 8, Classes. This week we're covering Chapter 9, Inheritance and Interfaces. I previously released a video on the inheritance basics, and now we're covering Section 9.2, Interacting with the Superclass. If you didn't already review the Section 9.1 video, I suggest you do that because I did have to go into a bunch of the details that we're going to be covering in 9.2, and so I won't be going over those details again. The first thing in Section 9.2 that the book talks about is how to call overridden methods. And we've already done that from my previous video. Here again is an example of calling the toString of the superclass here, and we use the form super.toString. And we also learned in Section 9.1 that if you want to call the constructor, you just call super without anything. This actually does follow the same format of doing super.to.something, but remember that since a constructor has actually no name to the function, that's what's happening here, is that we just call super without a name. Okay, so it does follow the same format. The next section of Section 9.2 is about accessing inherited fields. So in a subclass, if you want to access a field of the superclass, you won't be able to just access any fields that are there because they should be declared private. Instead, you're going to use getters and setters, as I've previously shown. We'll go look at that code in a second. A lot of people look at this and say, well, if you're going to have all these getters and setters, why don't you just make it public? And the reason is you want to encapsulate your data. So it's possible that you might in the future want to go back and change the implementation. Let me switch over and show you that implementation. Here's that example. The secretary extends employee. We've created an int WPM, and we've done all this, and you might say, well, you know, instead of making this private, we'll just make it public, and then everyone can just access, instead of up here in my client code where it says secretary, well, you'd have to do secretary.getWPM. Okay, instead of doing that, you could just say secretary.WPM. Okay, here's the problem. Let's say that someday I need to or want to change the implementation of WPM. Instead of just being an integer on its own, maybe I want to put this as part of a different object, or there's some way I can derive it from the other fields, and so I don't want to store an integer anymore. Well, now you're stuck because everybody else in the code, if this was public, everybody, all the clients, would be just saying s.wpm. You can't go and change all your clients. So, but as long as they're using getWPM and setWPM, you can go and change the implementation to whatever you want. You no longer need to have a WPM member variable. It could be a different object that somehow you can derive the words per minute, or maybe you don't care about words per minute anymore, and you just want to get rid of that variable. Well, you can do that as long as you don't expose what the implementation is. So in the book, when they're talking about accessing inheritance fields, they actually bring up a different example about stocks, and that's because these simple examples, mine included, don't have enough information to really show accessing inherited fields. So from this secretary class, I'm not actually accessing any of the fields of the employee. The only field that the employee has are the name and the hours. I am, in effect, accessing the name by the toString. We can try to do, we could replace this and say, okay, let's change this to be, let's start out with secretary, colon, that's probably a good way to start. And then let's do, instead of the toString, let's do getName. Oh, I gotta finish the quote here. So now we're gonna get the name, which would be Mike Jones. And now this, just to be, I should probably include the hours, the get hours, but just to show you that it's actually running different code, I'm just gonna run it like this is. Okay, so I'm going to hit run. All right, so now it says secretary, instead of employee, it says secretary Mike Jones, and then skip the hour, and then it does words per minute. So that's a really trivial example of accessing the superclasses fields. There's also, yeah, hours. I can do super.getHours. So that's how you access your superclass fields. So in section 9.2, we've covered calling the overridden methods. We've covered accessing the inherited fields, and the third one is calling the superclass's constructor. So we've done that here in the constructor for secretary. We've called the superclass's constructor super of name. The next two topics the book covers are the object class and the equals method. These are very intertwined. So all classes are derived from the object class. And we don't really show you the code for the object class, but it is the most primitive object, which only has a few methods. The ones that are interesting to you at this point are toString and equals. You remember from 142 the string class, and we learned how if you use equals equals, that will only test whether two strings are actually the same string versus whether they contain the same content. We learned that if you use dot equals, okay, that works. Now, how does that work? It works because somebody in the string class has overridden equals to not be whether it's the exact same object, but whether the two strings contain the same contents. And similarly, we saw earlier in my section 9.1 video, if you just call toString without having overridden toString, it's just going to spit out the memory location. That's the default Java behavior. Instead, I had to override toString to actually print out the full string. So I have already shown you the toString. I want to take a look at the equals, okay, what I was just talking about in this code here. So right now, if I have, let's create two secretaries. Okay, let's call two secretaries. So let's create a second secretary as 2, and we'll give them the exact same name, Mike Jones. Okay. And instead of printing it out, let's say if S1 equals S2, same, else different. Okay, let's try running that, see what happens. So it says different. Why did it say different? Because even though these two objects have the same, they're going to have the same names, they're going to have the same hours, they're going to have the same, because they're secretaries, they're going to both have the words per minute. They have both, all of those fields are the same. They're going to be different for the same reason that when you compare a string 1 equals equals to a string 2 with the same contents, they show up as different because they're not the exact same memory object. So how do we fix this? We are going to override equals. So the book shows an example of this, and I'm going to basically do the same thing. So I'm going to do public. There's a function called equals. It returns a Boolean. And it takes an object O. Now, just to quickly show, let's first check and see what this says. It must return a type Boolean, yes, and it overrides, yes. This is all fine. But let's say I put in employee. Okay, if I write this function to take type employee, does it, value is not used. Oh, okay, one more thing I got to put in here. If I actually tell it at override, okay, that forces the compiler to do some compile time checking. And now it says the method equals employee of type employee must override or implement a supertype method. This is telling me that I'm not actually overriding. Okay, why am I not overriding? It's because equals in the object class is defined to take a type object. Okay, so we actually have to use type object. And then how do I want to compare to employees? Well, what I'm going to do is I'm going to check the two different fields. So if I want to say you're going to see I can't do it without explaining this bit first. So we can't actually get any of the employee fields out of an object O. If I try to do that, I'll just show you. if O dot, so I want to get the name first, get name. See, notice how get name is not there? Okay, O dot get name equals this dot get name. See, now notice how get name is there? Okay, then return true, else return false. Okay, so this doesn't work, and the reason why, let's take a look at the error. Get name is not defined for the type object. Okay, that's because, again, object doesn't know anything about get name. Only an employee does. So what I have to do is I have to define a new variable, employee equals, and then we have to start with O, but then I have to cast it. I have to cast it to be a employee. Okay. So now let's see what it was saying. Get name. Oh, you're right. I still using O. I'm gonna make it E. Okay. So now this is all gonna work. All right. Now at this point, I'm only checking the name. All right. And notice again that I'm using equal. That's not gonna work. We actually use dot equals for the exact same reason that I'm doing this override. Okay. So let's try running this. So last time it said different. It still says different. Why is that? Okay. So we've got, oh, yep, same reason. We can't actually do equals equals. We need to do dot equals S2. Okay, now let's try it. You're probably starting to wonder if this is real or not. Okay, now it says the same. Okay, and just to show you that it is real, let's set a breakpoint in this code right here. And actually, let's set a breakpoint in the original code up here, just so you can see it. I'm going to do run. And by the way, toggle breakpoint is there. Okay, but you can double click in the left. Okay, we're going to debug this code. It's going to come down to where I set my breakpoint. I'm going to run step into, which is F5. Okay, so when I did that equals, what it does is it calls this equals function that I just wrote here. Okay, and it's going to convert. I'm pressing F5 manually now. When I press equals, it's actually getting the name, and then it's going to get the name again, and now it's comparing these two, and now it's returning true. Okay, so that's my proof that it's actually doing what I said it was going to do. But this is not completely correct, right? Because there are two different things that could be here. There's hours. So for example, if I set s1.set hours to 50, and for s2 I do s2.set hours 60. Okay, these two employees are not the same, but when I run it, it does say the same. And that's because we're not paying any attention to hours. So let's go down here. And e.get hours dot, and that's going to be an integer, so we don't have to use dot equals, equals to this dot get hours. Okay, then it's going to return true. Okay, so now let's try running that code. It says different. Okay, so that's good. Now let's set this to 50. And instead what I'm going to do is, these are secretaries, so I can do set s2.set WPM. One is going to get 85 words per minute, and s2.set, again, you'll find it there, this does 90 words per minute. Okay, let's run it again. Oh, no, we don't. It's because, oh, I just got to put it S1. Okay. Okay. It says that they're the same, but they're not the same because the words per minute. And so words per minute needs to be tested as well. So can I just put in here and e.get WPM? Let's try it. E.get get, oh, hey look, there's no get WPM. Why is that? That's because this is an employee. An employee has nothing to do with words per minute. A secretary has something to do with words per minute. So guess what? We have to go into our subclass, secretary, and change it here. So now we need to do the same kind of thing. I'm going to just copy this to start. All right, so public Boolean equals of an object. We're going to no longer create an employee, but a secretary. Okay, so we're going to force it to a secretary, and now instead of get name, what we're going to do is we're checking get W. Here, let's see if e.get. See, now get WPM is there. Dot equals this dot get. I guess I got to type the whole thing in. This dot get WPM. Okay. And we don't need to check the second thing. We just have to check that first thing. Actually, not quite true, right? Because we have to. Okay, first of all, not dot equals, but equals equals. This dot get WPM. So in fact, let's do that. Okay, we're just going to check the dot get WPM. Run it. And now it's different. Great, except this is not actually doing everything correctly. So let's set these to be the same words per minute. But here, let's just run that. Okay, so this should now say it's the same. Now let's change secretary S2 to Mikey Jones. It still says they're the same, but they are no longer the same, right? The reason why it didn't tell us it's different is because we are not calling the superclass equals. We actually have to check that the name and hours are the same. So what we need to do is to call super.equals on the object and the words per minute. Okay? So this is now going to check the name and the hours. This is going to check the words per minute. So now let's try running this. So it was saying before it should come up as different. It does. And let's go back and actually change this back to Mike Jones. And now it's the same. And notice how I tested every single piece individually. Always when you're writing code, you can't just write one test. You need to write enough tests that you execute all of the possible code in your function. Okay. All right. So that is dot equals. The next thing the book talks about is the instance of operator. So you just saw me go in and type force an object to a different object. Here, this is converting an object to a cat. But is that always safe? You don't actually know if that's safe to do because you don't know if the item passed in is actually a cat, because Java can't check the type if you're going to call it an object instead of a cat. So there is a Java keyword called instance of, and you use the format of some object instance of another object. It returns a Boolean. You can check to see whether it's the right type. Let's go back and take a look at the code. First thing I want to do is illustrate why this what I've done so far is not type safe. So let's go back up to the client code. So right now we're checking two secretaries, right? Yeah, okay, so let's create a second employee. E2 equals new Jane Doe. Okay, so we've got a new employee here. And what happens if I, instead of doing S2, put an E2? Okay, first of all, are there any compile time checks? No, no problems whatsoever. Great, let's run it. And kaboom, this is terrible. Employee cannot be cast to secretary. Okay, so the problem is that this function is defined as taking a type object. All things are objects, so it's not going to complain at compile time. But as soon as I went and tried to access the words per minute, it crashed. Okay, so let's fix this. So actually here in the superclass, this is where we want to check it. Okay, so right now I'm just going ahead and forcing this to employee. Instead, what we can do is actually check the instance of. So I can say if O instance of employee, then force this. Actually, I'm just going to check the tabification of everything. Yes. Okay. We've got a few errors. Ooh, lots. So there's a lot of errors here, but one of the key errors here is talking about E can't be resolved to a variable. What the problem is that I'm defining it in the if statement, or declaring it in the if statement. I don't really want to do that. I want to put it out here. Now, once it sets that, then we should get rid of employee E. That should be fine. O instance of employee E dot get name. Let's see what are the others. Local variable E may not have been initialized. Yes, that is true, but E cannot be resolved. That is not true. There's two ways I think we can fix this. One is we need an else. Okay, if it's not an instance of employee, we need to return false. And the other thing, oh, okay, that fixed everything up. Okay, so what this should do now is if the object is not a employee, it should return false. So let's go back to our client code. So here, where I have returned, well, actually, it's still going to fail. The reason why is because it's checking if it's an employee. It is an employee, okay? But now what I need to do is to do the same kind of check down here in the subclass. Because it's still going to work because the secretary is still an employee, but the part where it really blows up is right here in the get WPM. So we're going to copy that same code, modify it slightly here. Okay, we need to check whether it's an instance of secretary. Paste this here and just declare it. If O is an instance of not employee but secretary, then we're going to force it to a secretary. And now when you call e.getWPM, this will work. Okay, so let's try running that. There we go. Okay, so it says different. So the reason this doesn't crash now is because even though we have an employee here and we're comparing it with a secretary up here, it now checks to see what the type is. And it's actually going to call both of those equal. That's actually an interesting exercise. Let's go ahead and set the debugger, clear this point out, run, debug. Okay, when you get to this equal sign, I want to show you what actually executes. I'm going to step into F5. Okay, so where are we? We are in the secretary's equals code. Okay, so it is a secretary object, so that's correct. It's going to check this, and it's going to return false right there. I was actually thinking of, I think I need to actually do a different one here. Let's put in a second test. Let's copy this, and let's replace this with secretary too. Okay. So let's run this again. Stop the debug and run debug second time. Okay, so I'm going to step over this code because we know why this is going to print different. We just saw that. Okay, now here I'm going to step into. Let's see what happens. Okay, at first it's going to check to see whether it was a secretary. It is. Okay, now we're going to call equals. Guess what equals it's going to call? Is it going to call the secretary equals, or is it going to call the employee? It says super. that tells us it's going to go to our superclass equals. So this is the superclass for employees. And I pretty much want to step over this. It's going to check that equals, and then it's going to return true. Okay, we're back here. Then it's going to check the e.getWPM. So this, of course, is, since getWPM is only in the secretary class, it's going to call the secretary's getWPM. And then checking the other getWPM, and now returning true. Okay, so hopefully that shows you how you can override .equals and the code that you need using instance of to be able to properly override .equals. If you don't use the instance of, your code could crash. At this point, you should stop the video and go to practice it and actually do the problems from chapter 9, section 9.2, which include self-check 8, self-check 9, and I believe, no, just self-check 8 and 9. So do those two problems. Generally, Practice It has all the problems in the back of the book, but for some reason chapter 8 does not, or sorry, chapter 9. So here is the self-check chapter 9.8. It's going to ask you to kind of figure out which methods is it going to call. This is kind of similar to the problem I just did with the .equals, trying to figure out when you call something, which class is it, the subclass or the superclass that gets called. And then 9.9 is another extension of that. And so Practice It will, if you haven't already registered for Practice, it's very easy to register for it, and it'll automatically tell you what you did right and wrong. So just to summarize section 9.2, the first thing we talked about is how do you call overridden methods. So this is an overridden method here, toString. Here's another overridden method, equals. We talked about how you access inherited fields. So inherited fields you can use here, there's an example here where we call the super.getName. And we talked about calling the super's constructor. So you just call super. You have to use the same parameters. And you always want to call the superclass's constructor. And then we also talked about the object class. So object class implements .equals here, which you can override, as well as there are a couple other things. toString. toString is the main thing. So that's why we overrode toString, because we want to get special behavior and not just print out the memory address. So we talked about the object class, and then we also talked about the instance of keyword. And again, the instance of keyword, it can be useful for equals. It can also be useful for polymorphic code, and that's what we'll be talking about in section 9.3.